Okay, I hope I'm audible. Uh, so, my name is Abhishek. I'm doing a bachelor's degree in mechanical engineering from IT Bombay. Uh, in today's video, I'll go through a project. It's not a project; it's a problem statement which we are going to solve. So, uh, I'll just share my screen and show exact problem statement. Uh, just wait for a second. Uh, wait. Right. Okay. Uh, Sure. Um, I hope uh, my screen is visible. So this is the problem statement I got uh, maybe 2, 3 months ago. I even remember. So this is actually for this problem statement is actually for a internship role. I mean, kind of I would say a project before they take an interview. So this problem is basically on churn prediction, which is again a very hot topic in quick commerce and yeah. So there's a company called Pampay which actually made credit cards for children. I mean, a person less than 18 years old. So let's go through the problem statement slowly, and then I'll tell you exactly what is the business context of this problem and what we are exactly going to do. So see again. Uh, so first of all, you need to understand like what this churn prediction means. So see, so every company have a target audience. For example, FAMPay. This is a problem statement by FAMPay. I'm taking the same company as example, FAMPay. So FAMPay actually made credit card for children, right? Uh, People less than 18 years old, right? uh, Credit card, debit card, I really don't know. So basically, what they have a target audience, which is mostly people less than 18 year of age. Simple. But what does churn mean that your target audience is going? So, for example, for example, you are a company. What you will do, you will try to acquire more and more customer for a company. Plus, you don't want your existing customer to go out of your like business or company, whatever you say. Okay, so this is what is exactly a churn prediction problem in which you really don't want your customer to go out of a company or out of your business. Okay, so for that we do churn prediction. So what is churn prediction? In which for a particular customer we will give a probability. So, for example, there's a person X. I will say the person X has probability of 25% that he will leave your services. Very simple. And this is exactly what we do in churn prediction problem. So, for example, if you ever have used Septo or Blinkit or maybe Instamart, you got something like of 100 rupees of free cash, maybe in month end or something. So that criteria, for example, for you, like Instamart gave you 100 rupees for free, but maybe for a friend, it only gave 50 rupees. And it depend person to person uh, what exactly amount will get as a free cash. This is because of this churn prediction. This is because, for example, let me say, just taking an example. For example, you are using Instamart and you are just you're not using the app much, okay, but you have used the app. So what companies want you to be, because company doesn't want to spend the customer acquisition cost, because for quick commerce the customer acquisition cost is very high. If I say about Zepto or Blinkit, it is it is like like above 1,000 or maybe around 1,000. Okay, it's very high. So they don't want to acquire new customer. They actually want their existing customer to be there on their platform. So what they will do this churn prediction analysis. Okay, and for example, for you, they got like you are 90% probable that will leave the platform in the next 15 days, 14 days, whatever their statistical metric is. So they will give you cash rewards, for example, 50 rupees, 100 rupees, so that be you be still there on the platform because of that bet, that 100 rupees, right? It might be possible your friend get 50 rupees because he's a person who's like always using Instamat and it's not that much probable to leave the platform. That's why he got 50 rupees. Yeah. So I hope you understand exactly like what is churn prediction. So basically, we are giving a prediction to a person X, like how probable that person is to leaving the platform. Very simple. So for that, we have some data. On data, we will do analysis. Okay. There are again after churn prediction, there are again so many things, but let's just focus on the first uh like, for this problem statement. So this is what if you see in overview. In fact, we're mission to blah blah blah. Not important. Uh, so see, the key challenge is understanding which user are at the risk of become inactive. So inactive is a very good one. So inactive means churning, correct? And developing strategy to retain them because retaining customer is cheaper than acquiring a new customer. Very simple. For this assignment, we'll develop a machine learning model to predict the user churn, blah, 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 blah. Okay, very simple. This is a business context. Like, this is what exactly I've told you right now. So, same thing. So, you don't want to lose a revenue, transaction revenue, or whatever, acquisition cost, blah, blah. Okay, not important. Okay, now let's talk about assignment details. Okay, right. So, right now, if you see, you have two tables. For this problem, you have two tables. One table is exactly for what I say customer data in which you have user ID, registration date, and whatever you say. And the second table is transaction data. So how much transaction you did, and that is exactly stored here. So these two tables are available for you. And based on these two tables, based on the features available in these two tables, you have to predict for each customer what is the probability of being churn. Very simple. So here's the definition of churn. Let's read it. So for this assignment, we define churn as someone who hasn't made a transaction in last 14 days. Okay. So because that person is probably going to leave the services, that's why he didn't made a transaction in last 12 days. Okay. This represent in a field it is called is active. Okay. If it's zero, it's churn. If it is one, it is called active. Okay. Very simple. These are a list of tasks. We will do most of these as far as I know. Yeah. So I guess it covers everything very comprehensively, and I don't think I need to add anything. Uh, Development we will look at later, but for now it is okay to be there. Okay. Deliverables and values of success. Nothing submission. Okay, it's okay. So let's talk about first. Let's talk about the approach, like how we would solve this problem. It's a simple data science pipeline. Let me just give me this time to open Canva. I have made some. Okay, I have to open Canva, right? Hmm, I'm not able to open. Yeah. Okay. Okay. Uh, Let me share my screen first. Wait, uh, share and yeah, share. Right. So, so this is a basic, uh, it's a basic data science pipeline, right? So you have data, you do data cleaning. By the way, this data is already very clean, and you don't have to do much data transformation or such things. But this is what exactly a pipeline is. Okay. So this is you have data, you have data cleaning, you have EDA, which is very important. So for example, because we are doing analysis, so this is basically this comes under like of course this is data science, but mostly it is analytics because you have to understand the pattern and all, right? So EDA is something that's very important here. So EDA, okay. Uh, I have this right. Yeah. So this is very. Oh, no, I can't use this right. Yeah. So EDA, right. Next is feature engineering. Like I don't think there's much we could do here, but we will see. Like what kind of feature we make. We can make like for example, we have dates. For example, we have dates for last transaction. So you could find like how much days have been like the person didn't use their app or your credit card, right? You can find a number. So for example, last 15 days or like 25 days, he didn't come online. Like like that. So is there something we have to think about the feature engineering? Okay. Now the second last thing is model. So this is very important. This is where exactly a data scientist should think and which model to use, how to like do hyperparameter training, and then uh, you have to also like verify that model, right? So yeah, okay. This and then you have model evolution. So this is the next part of it, right? Then there's one more thing which is deployment or like development. So for this project, I'm leaving that. That is not for this project. Because this is a very analytical kind of project. So I'll take that later in some other uh, project. So okay, so uh, for this video, I would say like this much is enough, I guess. At least to understand the problem and the way to tackle the problem. So this is very common. I mean, this pipeline that I'm showing here is very common. Like, everyone does it. I would say so exactly like how I will solve this problem is I'm not going in a pipeline manner because the best way to go in a pipeline manner because for example if you're sharing your code with someone so at least the pipeline should be intact so that they can easily put your uh, put your data and perform analysis. So pipeline is better, but because I just want to be being this EDA part or this feature engineering part or this model selection part, evaluation part to be segregated, so I'll do in different ILPY file and so I'll not follow the pipeline already. Okay. The second thing is even it is written here in the problem statement if you see let me check for the yeah, not this. Wait, uh, mm, 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 mm. Where is the problem statement? Yes. Mm, again, I have to fill my this. Yeah. Okay, so if you see here, so this is written here like uh, deployment. So create a Python module that process the whatever new data and transaction data. This is why I'm saying because the deployment, sorry, the pipeline is important. For example, this is the data you have, right? This is the data you have. So, uh, I don't have to write that. This is data. This is the data you have, and again, this is second table you have. So maybe this is basically the data they have shared with this assignment is a fake data, of course, but they want to test this on their actual real data. So So they want it to be delivered in a way that they could actually perform this analysis using their own data. So this has to be in a pipeline, right? So that whatever transformation, whatever feature engineering you have done there, it should be intact. Apply the feature engineering pipeline. That's right. They have written their pipeline also. So one should do it is a Python manner, but I just want to segregate code. That's why I'm doing different IMPF. Okay, I guess this one is enough for this video. I'll meet you in the next video in which we'll do this part, which is the EDA part. Again, I guess there's nothing much in EDA. This is important, but because the data is not very real, it is very fake. So I have already done this part. Honestly, I've done all these three parts. But because as I remember, the EDA results are not very astonishing. Okay. So okay, let's meet in next video and we'll start with the EDA. Okay. So I should stop this recording.